Paying attention to a couple of details about this as we get started. Continue logging in, but I need to look at the slides. Hold on. All right. Agenda. First thing, it's been a hot second since we've done this. And by a hot second, I mean a couple days. But I always want you to remember, and I talked about this in last block, and I'm going to say this in here. I don't think it's as much of an issue. By the way, I just noticed, did we all get our name cards out like we were supposed to?
Yep.
I meant to say that earlier, and I don't think I did. Please make sure you have your name cards out. Ms. Courtney is about to pass back your graphic organizers. She has unfortunately been pulled from our classroom 3 out of the 5 days that she's supposed to be here because of internship stuff at UA. So have your name card out so she can find you and give your graphic organizer back. Oh, how do you do this? Put it in your notebook. Y'all got a little folder thing in there? All right. While she's passing those out, one thing I want you to remember, I know that math can be hard for some of us. But I also know that it only helps if you actually learn it well. All right? I think it's been more in first block than it's been in here, but I need you to clearly hear me on this, that I care about you, which is why I'm going to push you to do and understand more than you've ever done in the past. Okay? Yes, some of us are coming into Algebra 2 without a strong Algebra 1 background, but that's why I need you to do the work I'm asking you to do. But math can be a lot less scary when we approach it with the right mindset. So, I'm opening it up. What is math?
Study of patterns and relationships.
There we go, right? I'm glad that we're all jumping into that conversation because remember, I am looking for your voice being a part of that whole class discussion as your active collaboration, right? So, math, it's the study of patterns and relationships. And the first part of being a mathematician, I feel like we're doing very strongly in this class. What is the first part of being a mathematician? Noticing patterns and relationships. That's the easy part. That's where we get started, is we notice the patterns and relationships. A lot of us are struggling because we've never been asked to go to the next level, which is the more important level. Once you notice the pattern and relationship, you've got to describe that pattern and relationship. When you can describe it, when you can use your words to explain it, that's when you started to develop your understanding. I regularly hear students say, Mr. Kinney, I know it, I just can't explain it. I need you to pause. I need you to hear me say this very clearly. You don't have to be able to explain it immediately, but if you can't explain it, you don't understand it as well as you think you do. Which is when you're going to run into trouble on assessments and you struggle on the assessments because, well, I forgot it, or it flew out of my brain. No, that means that we didn't understand as well as we should have in the first time. This is a clue, right? I'm not trying to be mean. I'm trying to tell you, if you can't explain it, that should be a sign to you that, hey, you need to do something to improve your understanding. You may need to ask more questions when we're going over content in class. You may need to come to tutoring. You may need to watch these videos on YouTube. You may need to study your notes. Go to Mathia. Do something to improve your understanding. I care about you, which is why I'm going to push you to be better. If I didn't care about you, I'd let you stay where you are. And I know some of us just want it easy. I ain't the guy for that, though. I'm the guy for what's good. I'm the guy that's going to help you be better. All right? Easy is not better. All right? And once we describe those patterns and relationships, we need to generalize them. Quick reminder on the active collaboration, but I'm going to go more heavily into the scoring rubric. By the way, Ms. Courtney, there's a couple in there that aren't here today, and there's a couple in there that are from third block. Yes. Okay. All right, so we're going to look at the scoring reminder because a lot of us got our graphic organizers back. If we did not get our graphic organizer back, that means I never got it from you, which means currently in the grade book, what you got? Zero. Now, you can always turn in things late. It'll be points off, but late is better than never. And if you turn it in late, I will give you feedback to improve your understanding. And when you get that feedback to improve your understanding, I will let you resubmit this graphic organizer when we have the test. And if you improve your explanation of these concepts, then I will honor that and I'll go back and change your grade. I'll make a note of, hey, they improved their understanding and this is the evidence that I have. I don't care when you learn it, I care that you learn it. It's all about the growth. So when you get feedback on these things, look at it, take advantage of it so you can grow and improve. So we'll look at that scoring reminder or the scoring rubric. We already did that practice, and we're going to look at lesson 2 here. So remember, and I think that y'all are doing this pretty well as a whole class, especially towards the end of that Matthew work today. What do you need to be doing in order to learn well? Communicating, what'd you say? Engaging, which means you've got to use your what? Your words, your thoughts, right? You've got to talk this stuff out. When you talk ideas out, one, you're going to have to explain it to other people, which again, if you can't explain it, you don't fully understand it. And so that should be a sign. When you have to talk these things out, maybe you have a misconception and someone's going to hear it and say, wait a second, I don't think that's right. Even if you as a small group can't figure out what's not right about it, that's when you can ask me and Miss Courtney. So, when you talk these things out, you're going to learn and you're going to grow. When you ask questions, I can answer those questions. Miss Courtney can answer those questions. Your peers can answer those questions. If you want to grow and become a better mathematician and earn the grade that you want, because I regularly hear kids say, I just want the A. I don't care if you want the A. I care if you've learned it well enough to earn the A. And I care about supporting you to find that level of success. Right? The A means that you learned it to that level. Alright? I'm going to support you to get there, but in order to do that, you've got to be engaging. You've got to be talking. So keep that in mind. Here, this is one thing I want you to notice. Right? This is the scoring rubric. It's a lime green sheet in your notebook. You can't miss it, and there's a reason why I did that. If you score a 5.5 or a 6, right, there's a little bit more detail here, but what you have shown me is clear, consistent, and more importantly, convincing evidence of your understanding. If you don't have a 5.5 or a 6, there's something that you can improve there. Now, if you have a 4.5 or a 5, there's still evidence, right? There's still clear evidence of conceptual understanding or procedural fluency, but there's definitely something that you may want to improve. If you had a 5.5 or a 6, I probably didn't give you any feedback, but 4.5s and 5s, I probably gave you some feedback to improve your understanding. Improve it. Go back. I probably made a note about how you could improve it or where you could go look to find more information, right? Improve it by the time the test rolls around, and I will rescore it based on your improved understanding. If you are at 3.5 or a 4, that's limited evidence of your understanding. That's a problem. I'm not saying that you don't understand it, but I'm saying that what you wrote there is not fully correct. And if it's not fully correct, and that's how you actually think about it, that's going to hurt you on down the line, isn't it? Yeah. I took the time to see your thoughts, which is one, why I ask you not to, Google things or copy from others, because then I can't see your thoughts, right? I need to see your thoughts so I can help you improve your understanding. If you're looking at those 3.5s and those 4s, you need to reevaluate. This may be where you say, yikes, I need to ask Mr. Kinney some questions. I may need to come into tutoring, watch the videos, do something, go back to the notes. If you're in that -1, which I don't think anyone got a -1 unless they just skipped it, but that -1 to 3, please note little or no evidence of conceptual understanding. That if you score that, you went super off. And so you need to reinvestigate those ideas, because if you don't fully understand those terms, if you can't explain it and use it, then you don't fully understand the math. I'm trying to give you feedback to improve your understanding. So look at your scores, look to see where you are on the rubric to figure out how you can improve your understanding. It's not a grade, like it's a score, but it's not a grade, and there will be a grade out of it, but it's not just that. It's information about how well you understand, or at least the evidence that I see. Does that make sense? Okay. Everything I do, it's more work on me. Like, it takes me time to get this kind of feedback, but it's for your good. Please take these seriously. And again, if you haven't submitted it, it's not too late. You will have points off because it's late, but if you get feedback and you resubmit on the test, all the late points go away. So turn it in, get feedback, improve your understanding, and resubmit on the day of the test. Or resubmit before then if you want to get extra feedback. So, we should already have our calculators out. I forgot to mention this, but we should also have understanding data in context. We need that task out to be able to complete the stuff that's on our calculator. Please go ahead and get that. I think everyone here has that sheet? If not, this is what it looks like. Does anyone not have this? Looks like everyone's good. Yeah. I know I saw yours.
I don't see it.
Oh, really quickly, someone did turn their graphic organizer in without a name. Anyone know who that is? You want to look at it, Keyshawn, see if it's yours? You say you need a copy of this? Oh, you turned yours in. You think this was yours? Maybe you got stuck in a different. I'll look to see if you got stuck somewhere else. But if it did, that means I haven't given feedback on it yet. I'll find it and give you feedback. Come back to me after enrichment, or after third block. I'll have it done. Yes, ma'am.
I need one.
Okay, I'll print one out for you. All right. All right. So let's get started with this. Couple of quick details to remember. We're trying to use calculators to identify appropriate trend lines to approximate data. Keep that objective in mind. Remember, it's hard to learn what you're supposed to learn if you don't know what you're supposed to learn. So, literally a trend line is a line that shows a what? Trend. That's it. Specifically a trend through data, because data is usually scattered. You're not going to have to create the equations by hand, but you are going to have to identify key features of a linear function. And so this is where we got through all of this on Tuesday? Does that sound right? Okay. Maybe Wednesday. It was one of those 2 days. I think it was Wednesday, actually. Today's Friday. Yes. So, got through all this, talked about all these details, and we got to this part where we went through the context of the problem, and we started on trying to create that equation. Some of us got there, some of us didn't, but you should have the file back to improve. Now, I want to pause and I want to point this out really quickly. If you don't interpret the variables well, here, it is almost impossible to do these next few pieces. So I'm going to write something on the board in a second, but I want you to remember this. In order to work with functions, what is the first thing you need to do?
Identify the function.
Okay, but how do we identify the function? Say it again. See the rate of change, right?
Yeah.
If you want to work with functions, you got to identify the rate of change so that you know what function you're dealing with. If you want to work with data, then you must interpret the variables. You got to do that. If you want to work with data, then you must interpret the variables. You must explain what the variables in this wording up here represent. If you are going to work with data, then you must interpret those variables. Okay? Now we're going to come back to some of this stuff in a few minutes after I give you all some time to work through this. But I need you to be very clear about this. You got to be clear about what the variables are. You have to think about the entire context. Because when you move down to what does the slope represent, you can't just write down the slope value. You can't just write down the number here. What does that number mean for the problem? That's what I'm asking about here. When I'm talking about the y-intercept, I'm asking what does that y-intercept mean in the problem? Okay? I'll wait a second and re-emphasize that. I see some of us writing this down. Okay? So, again, I want you to listen to this and understand this very clearly. If you want to identify what does the slope represent or interpret the slope, you have to understand your variables. And I'm asking you, what does the slope mean? So let's go back quickly. By the way, Xavier, was that yours? Or no? That graphic organizer wasn't? That's right, I already asked you and got that cleared. Keyshawn, you think this one might be yours?
Yeah.
So got it. And that's right, I need to look for yours, Xavier.
Yep.
That's it? Okay, remind me and I'll make a note of that in a second. Okay, so we looked at this problem on Wednesday as well. And so I want you to remember, what did we say the slope was for this problem? The slope was what?
50. That's 50 over 50 dollars.
50,
X plus 50.
50 what, Mackenzie? Divided by 1. Remember, there is the equation. We've got to separate this. This is not slope. This is the slope-intercept form of a linear equation. It's important, right? Because that's not just any old equation. It's not any old function. It's only the linear equation, right? That's the slope-intercept form. But my slope was 50, and I'm glad that a couple of us remember that detail that is divided by 1. Because how do we calculate slope? What are a couple of ways to calculate slope?
Changing y over changing.
So first, rise divided by run, and
Changing y over changing x.
reword that.
Changing x divided. No, changing y divided by.
There you go. So I want y'all to notice that that's 50 divided by 1 is not just numbers, right? And I also want to emphasize, it really, in the equation, just said 50x, didn't it? But if we're talking about the slope as the change in y divided by the change in x, well then I need to know what it's being divided by. And it's understood to be a 1. The slope always has those two parts to it. 50 divided by 1. Well, knowing that that 50 is the y, 50 what? Dollars in gift cards received, right? Notice the full context is we're talking about dollars in gift cards, and so I need to acknowledge that, right? Per one what? X is the months of the school year, right? And so we would want to recognize that there's a context to this problem, right? First off, what's your question, Jesus?
So, $50 being a gift card, 1 being a month, could that be what you put in the input variable represented or whatever?
Well, remember the input, is that my X or my Y?
That's your X.
So the X would just be the months for this problem. Now, remember that second problem is a different problem, so you need to think about what your X is, what the independent variable is, right? And then the Y would be the, in this case, dollars and gift cards received, right? But what I'm trying to point out is, when we talk about this slope here, what we want to recognize, first off, what's the independent variable? Months, right? So, as the months, are they increasing or decreasing?
Increasing.
How do you know they're increasing?
Because it's going up by 1, 2.
Not just that, look here, this one is positive. We want to recognize positives versus negatives, right? So as the months increase by how much? By 1,
The money increases.
you receive, right? You talk about money, you receive how much money?
$50.
$50 a month.
$50 more, less?
More.
More.
It's a positive.
in gift cards. Notice I don't need to say anything else about months because I already talked about months at the beginning. And notice how I said as the months increase, right? Because that's independent. So as the independent variable changes, here's my dependent variable changing in context. You've got to understand where your x and your y are, though, in order to do something like this, which is why if you want to work with data, you must interpret the variables first. Now, we're not going to go into all the details for this next part, but we also have a slope and we have a
Intercept.
y-intercept, right? Now, the y-intercept is a b, which in this case b is 15, but is that the entire y-intercept?
No.
15, no, 0, 15.
We need to always remember, a lot of us on the intercepts on the graphic organizer just talked about, oh, it's when the function intersects the y-axis. Yes, but that's only, we can only see that on a graph. In general, we need to know that the x value is 0. Because now we know what x means, or the x variable is in context, and we can interpret the y variable in context. So, when you work on interpreting the slope and the y-intercept, you need to think about the context of x and y. Any questions about that? We good? So, now, if you have not finished getting an equation, talk with your group to make sure you get an equation. If you have not interpreted those variables, those intercepts, talk with your group about interpreting those variables and intercepts. Any questions? Are you going to probably run into questions as you do this?
Yeah.
Is that okay? Yes. What are you going to do when you run into those questions? Ask your group first, and if no one in the group can answer the question, what do? Ask me or Miss.
Sir.
Come on, we gotta learn her name just like she's gotta learn your name. Thank you, Miss Courtney. There we go. Right? I know she's been gone 3 of the 5 days, and I haven't done a great job of reminding y'all. But Miss Courtney will help you as well.
Oh, that's why I keep thinking Miss Rachel.
What?
I kept calling her Miss Rachel.
Rachel.
Yeah.
So, Miss Courtney.
My bad.
All right, let's get to work. We'll come back together in a few minutes.
Listen, listen.
The question is, what we put down where it says input and output.
What do we?
That's what I was thinking too. Let's see what it says. Alright. The input is yeah, the month. 1 being the month.
But I'm pretty sure there's no.
I got it. Yeah.
Top of the morning. My bad.
It's not just Y, what is Y stand
Well, remember, you're supposed to be on the
Stop.
concrete one.
Read that
Wait,
problem. That's not bad.
I don't know why I'm thinking about that.
I was using that as a model.
Why do we think
Oh, this
this
ain't-
one task in the first place?
It's the top, yeah.
I thought it was from the first part too.
Okay, wait, before you write the equation for that line, is it going through,
Yeah.
like,
I
all
realized
the
that. I was like, yeah, I need to.
do you know how to do that?
Roads and bridges are built with concrete. Buildings are planned for extreme temperatures. So what's the equation? Actually, let me tell you that.
So you add B, the X
Wait, so we on the job?
Is it increasing the Oh, okay.
So we need 2 feet and 100 degrees?
2 feet.
That's gonna be the age. And then increases 100. So what's our total degrees? 100?
I got it yet.
Record the linear model.
Yeah, I said it.
So y equals 2x plus 1. Alright, what did we say, 10?
Xavier, yours got mixed into the first block. That was the issue.
Y, right?
That's you, I assume.
And then
I know. That is you. Okay. Make sure you put your last name on there in the future. Because I have another
And
Xavier.
you just copy
And I
this
thought that
that we got in the
in the first block.
At least that's
Shit, I know that.
There you go back.
What is this? Oh my god.
Did you log onto your calculator? Dude, this is real hard to do without the calculator.
Higher temperatures.
That's the equation you should have been using, right? Have you and Juanicia been talking at all?
What? How did you get that equation?
Oh, it's back. Wait, no, it's not.
2 whole feet in this, in the eight.
No. This is why I sent this back out to you. Remember there was this data, and you fit a line to that data. You're looking at me instead of looking, look at that line. What, isn't there an equation for that line?
So you want to write that equation down?
Yeah, is that the right one though? No, you need 2.2. Right, we're on task 2. There's an equation given to you. Sorry, I was trying to check on others, but you gotta remember that. Thank you. Okay, we're gonna go over parts of this together at this point. I do want to point out, and like I know that I was a little distracted trying to get some things back to students because just got misplaced. But we're gonna continue with this on Monday. Yes, we are here Monday. Wow, guys, sometimes you just have like your brain's just not fully working. Okay, I'm glad at least someone's like, yes, Mr. Kennedy, I get it. Can you see that? All right. So really quickly, just to get that quick refresher, because y'all didn't have to do this time. I can't see my data. How am I going to do that?
Go to menu.
Menu,
Zoom.
and then zoom,
And then data.
and then zoom data, right?
Mm-hmm.
And it goes straight to that data. What do I need to do now to graph?
Put a little through it.
Huh?
Put a line through it.
But I got to go to menu.
Yeah. And then graph. And then functions.
All right. I'm going to do like 0.5x because I think it was hard to see that equation originally. It's a little bit better. All right. So remember, you can move this line around. And then, so I move the y-intercept. Now I'm rotating. And I want to point this out. And I want to ask, is this a good trend line? Why not?
Because it's not connected. Or points, I mean.
Right, notice it's pretty good for these 3 points, isn't it?
That's the biggest thing.
But it needs to kind of split the data in half. A good way, huh? I'm going to keep moving it, but what I was going to say is a good way to think about a trend line is the trend line is kind of like the average of those data points, right? So the trend line is much like the average for points in a scatter plot. Really bivariate data, but We'll just focus on it like this for now. Right? That's kind of what we're thinking about when we see a trend line. It is a line that's approximating those data points, right? It's kind of like the average. An average approximates your data. So what about this? Would that be good?
Sure.
Yes? Did anybody else have that equation?
Something like
Close to that? I'll be honest with you, does anyone have the same exact equations? Probably not, maybe. I might move this up because now it's not great for these points. So I might go like here and rotate a little bit more. Notice it's kind of trial and error to get the best possible. I think that might be a little bit better. See how this kind of really kind of in the middle at this point? Alright, so just playing around with it to get a little bit better. So now I move to here. Play from that current slide. Nope, that's not the one I wanted. That's what I want. Okay, so record the linear model here. I think mine was f of x equals 0.068x. Was it minus something?
Do we have to be directly on yours? Like,
No.
we got, they're all gonna be like 6'3".
So let me say this, okay? There is I need y'all to hear me on this. There is what's known as the least squares regression line. That is the absolute best trend line. But that's not what I'm asking you for right now. I'm just asking you for a trend line that approximates the data. So it doesn't have to be exactly the same as mine, but that's the one I got, right? But we do need to have all of this together. What does the input variable represent? Temperature? How'd you know the input was temperature? Okay, so I'm going to show you two things. First off, remember, your input is the independent variable. Doesn't the temperature affect the expansion and contraction?
Yes.
Also, the TI Inspire is really nice to us. Look at this corner right here. What's my X? Temperature, right? It's going to tell you that, right? So when I come over here, and I'm looking at what does the input variable represent, that is the temperature, or let's say the input, right? That's my X, is the temperature. Is that everything in the context here?
Yeah.
No. Let me ask you this. Is there only one way to measure temperature?
Fahrenheit.
Oh, this is temperature in degrees Fahrenheit. I think this is how you spell that. If it's not, I'm a math teacher. Get over it. So it's degrees Fahrenheit. I wish I knew for sure off the top of my head, but I don't. That is? Thank you. I appreciate that. All right. So the input X is the temperature in degrees Fahrenheit. I go into the full details, not just temperature. There's a unit there. What does it say for the Y?
Feet.
Feet. Now, I do want to point this out. Is feet the actual context, or is that the unit of measurement?
Unit of measurement.
So what's that feet talking about?
How many
Expansion.